Welcome back, everyone. You asked to find the area inside the inner loop of r equals to 1 plus 2 sine theta. So first, you need to make sure you feel comfortable about the object and how to graph this object. Otherwise, how do we find the upper bound and lower bound when we're dealing with these types of objects? So try to practice and use the table to see the behavior of these types of functions. Here you have r equals to 1 plus 2 sine theta. Theta is changing and r depends on theta. So take a look. When theta is equal to 0, your r is 1. So when theta is equal to 0, your r is 1. You can plug in more angle. I didn't have enough space to plug in more angles. You can plug in pi over 6, pi over 3, and so on. When theta is equal to pi over 4, your r becomes 2.41. So theta is pi over 4, and the unit for r is about 2.41. If I plug in pi over 2 into this function, I get 3 back. So far, I see the behavior of this object to be like this, okay? So far, it is moving this way. But I need to plug in more angles. For example, if I plug in 3 pi over 4, at 3 pi over 4, it is r about 2.41. Okay, so far, so good. If I plug in 5 pi over 6, the radius is 2 units, all right? Okay, very good. And if I plug in pi, I get the radius equals to 1. So at angle pi, I have radius to be 1 unit. So far, I have this behavior. If I continue, for example, if I plug in 7 pi over 6, my radius becomes 0. This is important, everybody. This is very important. Why? At 7 pi over 6, the radius becomes 0. 7 pi over 6, the radius is 0. It means that it is located here. But if you plug in more angle, you see the behavior of your object becomes like this. Very good. So, what if I plug in 5 pi over 4? 5 pi over 4 gives you negative 0.4. Negative 0.4 is about here in the negative part. This guy is here. So far we're connecting this. If I plug in 4 pi over 3, the radius is negative 0.7. So this guy is located here. Now, if I plug in, for example, 3 pi over 2, this guy becomes negative 1. Negative 1. So far, we have this behavior. You can continue this process and form the inner loop. So we want to know what is this little area. Remember that when it comes to graphing this in polar world, we flip this, and this shape, when you Google it or when you try to graph it, you see this object instead of this. You see that, hey, I have the following object. They flip this inner circle up because you have negative radius. So we look at the reflection. But basically, this is the way that you graph, and eventually you flip this. So this is an internet, and Google it or try to graph something. Graph online. You see this version rather than this version. This is how we actually graph this object. So we want to know what is this guy? What is this area? But because of symmetry, you don't have to compute the whole thing. You can say that, hey, I can just find this little area here. Just erase this little area, which is bounded by 7 pi over 6, and here you have 3 pi over 2, and then multiplied by 2. So your area is equal to 2 times the integral 7 pi over 6 times 3 pi over 2, a half r squared, which is 1 plus 2 sine theta squared d theta.